Let me press that. Okay, we're live now.
Okay, shall we start then?
I think we'll wait 2 more minutes.
Okay.
Let's, if everyone who's listening right now, tell us if our audio is good and not any echo or buffering or anything like that. We'll get started at 7 sharp.
Yeah, we believe that we have licked our audio problems. We will find out tonight.
Well,
I
for
think.
people who were there last time,
Huh?
there's something going on with Doug's desktop that was causing the audio and the microphone signals to get tangled or something.
Yeah,
Oh,
probably a wood rat inside of my desktop chewing
Yeah.
on wires or something.
hopefully not.
Yeah, yeah, that's true. It does have some other purpose that I need.
Hmm.
Yeah, well, Scott, you got to come up to Julian sometime and join us. Maybe a little post-COVID moment, but bring your new scope up, and we could have a little galactic jam.
Yeah, that would be good.
It's the EV scope. Is that what it is?
It is. Yeah.
Okay, everybody, welcome. This is Doug Solisey. I want to welcome everyone to our star party tonight on behalf of the Julian Dark Sky Network and Curiosity Peak Observatory. With us tonight, we have Vivek Vijaya Kumar and Scott Cardell, Professor of Astronomy at Palomar College. And we've got a different star party than we've ever had before. It's about narrowband imaging, and you're wondering, what does that mean, narrowband imaging? You will soon find out. So, and I just wanted to also mention to our viewers that the Julian Dark Sky Network has just worked out our application for Julian to become a dark sky community and submitted it. We had it initially reviewed, made some revisions, and we're pretty confident that it's going to be approved. At least that's our great hope. So keep tuned on that. So anyway, I don't think there's anything else to needs to be said. I'm going to let Scott and Vivek take over. Okay.
Okay.
Well, sure. That's exciting news about the dark sky application moving forward.
It is. We've been working on it for 5 years, so it's definitely been anticipated quite a bit. Yeah. Oh, I should also mention that um, Vivek is in San Marcos tonight, and
Yeah.
Scott, you're let's see, near Mount Palomar,
South up there in Valley Center.
Valley Center, right? That's the place. Okay. So, and I'm in Loreto, Baja California South. So we're all kind of meeting up here somewhere out in cyberspace. But Vivek's the one with the equipment, so he's
Yeah.
going to be piloting the show, and we're along for the ride and the commentary.
Okay, well, I guess I'll begin by explaining what we're doing here. So, we're trying to mix it up a little. Now we're going to use a different type of technology. So, this is the setup for tonight, and it's just an 80 millimeter refractor, so it's not a lot of aperture on a equatorial mount, and we're using a monochrome camera with filters, but the thing is we're going to be using narrowband filters. And narrowband filters are filters that isolate the specific spectral lines on which these type of nebulae, emission nebulae, emit at. So we're going to use that to try to, because when you only take the light coming from the nebula itself and you isolate everything else away, you can help deal with light pollution and the light from the moon, and that can give you a lot more detail than if you were just trying to take a normal exposure with a full spectrum. So that's what we're going to be trying to see what we can do with narrowband filters. And there's three different filters. There's hydrogen alpha, which is what you're seeing right now, and I can switch to oxygen 3 or sulfur. So we get to see three elements tonight. And I guess we're going to first start out with the California Nebula, but just having this one specific channel isn't enough. We want to have some color, so I'm going to start this so that it can take some data on the luminance filter, and I'll leave it to that. So, if Scott, if you want to talk about what the California Nebula is, we can do that.
I can do that. I can also wanted to mention that basically every color photo you see from professional astronomy has been done with narrowband filters. I mean, this is the way it's done. Astronomers do this to deal with light pollution issues, but they also do this to hone in on light emitted from certain things. Just like we saw that first image there from emission from hydrogen gas, they can tune their filters to look at specific wavelengths, and they take monochromatic images like you saw there and then combine them to make color images. So this is the way professional astronomy is done. So what we were seeing was the California Nebula, and also called NGC 1499 for those that like that. But it's currently sideways compared to the state of California.
Well, I'm sure I can fix that real quick.
It gets its name just because of the vague resemblance to the state of California. I had somebody ask me once if there was a nebula for every state in
North America. The North America Nebula does it all.
There is a North America Nebula, but there isn't one for Oklahoma or Florida or New Jersey or any of the others. So California is special in a lot of ways, and here's mere coincidence that we have a nebula that looks something like our state. It's a cloud of gas off in the direction of the constellation of Perseus, around 1,000
I forgot.
light years
Let me show
away.
that.
Yeah,
We got to show what the objects are. For the filters, can you share the angstroms, please? So hydrogen alpha is at 656.3 nanometers, or just times that by 10 for angstroms, so 6,563 angstroms. Oxygen 3 has two lines, 499.5 and 500.7 nanometers. And sulfur, I think, is also a doublet, but they're roughly around 672 nanometers.
Good, because I didn't remember them off the top of my head, so I'm glad you've got that.
I don't know why I remember them.
Well, you use them. That helps.
Yeah, I guess. Well, let me turn on the constellations here. Okay, so there's Perseus. There's the moon. This is our main opponent for tonight. And if you notice the image, this gradient right here, this white glow, is actually from the moon, and that's what we're dealing with. So this entire white part of the image, that's because of the moon. So these are not the 5 nanometers of light that's coming from the moon is still enough to affect the image. We're going to try our best to combat that. But you can right now we're in Perseus, and that's on the western side of the sky. And right now I think the sulfur should be almost done. Okay, we have 30 seconds left on that. So right now, what I'm doing here, this is basically monitoring the equipment. So there's guiding to keep it on the target, and right now we're just trying to take a 3-minute exposure so that we can do some fiddle around with the image a little bit.
Okay. Could you say something about the palette that you're using? Because what?
Well, I guess we'll get to that.
Yeah.
We'll get to that in 2 seconds.
Okay.
I have to retrieve the image now.
Mm-hmm.
I think that's it. This should be sulfur too. If it looks like nothing, then there's not much we can do about that. Okay, there's something there.
Oh, we got something there.
It's kind of faint, but let's make that. Let's make it California-like, and there we are. Let's fit that. So I know from that what we have right now is there's no oxygen in the California Nebula that's tenable in a short period of time. It takes like a few hours because it's really faint. So for now, we're going to be doing a more unstandard palette to try to get an image. So basically, I'm going to be messing with the channels to get a color image out of them.
Okay, so this is going to be Vivek's palette you're using.
And it's hot. It's weird.
Okay.
Leave it at that.
And that again is a common thing in astronomy. They shoot black and white images because you get better resolution that way, with specific color filters, and then basically you use Photoshop or something, and you assign a color palette to each of
Oh,
the filters and then combine them. Typically, people would take the longest wavelength light and make that the reddest, but not necessarily so. And a lot of the colors that we see in images from, say, Hubble Space Telescope are not necessarily what a three-color camera would perceive. We see a lot of greens in Hubble images that aren't necessarily there, but it was the way that they decided to put the image
okay,
together.
this is the best. This is hot. I mean, there's so little S2 compared to the hydrogen. It's basically red, and in actual
Right,
true color, it's also red because it's mostly dominated by hydrogen alpha. There's very little sulfur,
right.
and that's where barely got some of it, if you can see the shape of it, and
Mhm.
didn't really show up much on this very quick
And so
combine.
you went with red for hydrogen
Yep,
and
then
green for the sulfur
everything else for sulfur, yeah, green and blue. Yeah,
and everything else. Fair
yeah,
enough.
it's like HOO, but I replaced it with S sulfur because there's no oxygen. I was planning for oxygen. That's gonna be a common theme for some of these targets, that there's not some oxygen, there's not some sulfur, so we're gonna have to deal with that. But I think I'll go on to the next target real quickly. So I think that was
Were you going to go to the Orion
42.
Nebula next?
Yeah.
Yeah. Okay. Messier 42.
Oh, it's doing a meridian flip. Okay, we might want to go somewhere else first. You want to avoid the meridian actively. Yeah.
Oh, sure.
Actually, I turned meridian flips off. I think we'll be fine. Yep.
Mhm.
Okay, why isn't that working?
Whoa, interesting.
The buttons.
Excuse me. Oh, okay.
Oh, there he goes. Okay, now it should be going to M42 right now. So let's show that on the screen. So that's the thing. That's right now it's near the meridian. That's not a great place for equatorial mounts to be because they're gonna eventually flip. But I think we're good for now since we're not gonna spend too much time there. But this nebula, it has a lot of reflection, a lot of dark nebula, a lot of emission. But for now, what we're going to be mostly looking at is only the emission of hydrogen, oxygen, sulfur from this nebula. Everything else will be cut off. But in exchange, we get to avoid the wrath of the moon. So that should help us.
Yeah.
So right now,
It's a great nebula, though. That's for sure.
we'll see it real soon. It's very bright, so it'll show up in the exposures while it's trying to find the target. So right now the telescope's taking exposures to find M42 and center it. So I'll be waiting for that.
And anyone who's got a small telescope or a pair of
There we are.
binoculars, I encourage you to look at it after the star party, and you'll see something there.
Yeah, it's in the Sword of Orion. So find the 3 stars for Orion's belt, and there's what looks like 3 sort of hanging down for the sword, and the Orion Nebula is the middle part of the sword, and it looks kind of fuzzy to your eye, and pretty impressive with like every kind of instrument.
Yeah, you can't miss. Looking at the Orion Nebula with anything is great.
Right.
Yeah.
So I see Fred in the chat says it's the best other than Eta Carina, which of course is way too far south for us to be able to see.
Yeah, that almost makes it not the best.
Yeah.
Well, for the northern chauvinists, yes.
Yeah. This will be. Oh yeah, these are 60-second exposures because they're very bright, so we don't have to wait that long to see something. Okay, there it comes. Nice hydrogen alpha, so we'll open that up. Open. All right, so
I just had to check. Eta Carina's only 22 degrees below the horizon right now.
Yeah, wow.
wow, sounds like we could do that tonight.
Yeah, just
Right.
get
If it,
in a plane and fly a few thousand miles south.
Yeah,
or if it's emitting neutrinos and your telescope is sensitive to them, we would be just fine.
yeah,
Okay. Yeah.
that'd also work. Well, the core is very bright, so we're overexposed to that, but we got everything else in good detail. If we took
Yeah,
longer,
there's a group of.
we would see if we took hours of exposure, we would see a lot of the emission nebula outside of here. Yeah,
I was just going to say that there's in that core area, there's a group of young stars that has formed from this, sometimes called the trapezium, and they're hot stars that are making this gas glow, and yeah, they're also making the central part of the nebula there just overexposed. But
yeah.
it's good to be able to catch this in the hydrogen filter here.
Okay, we got the oxygen now, I think. Yeah, this is oxygen. So
Right.
let's call there we are. So this one, let's look at the difference between this, because the differences are basically gives us, you know, a color contrast that we can get an image that isn't just, white. So obviously we can see there's some more hydrogen in this. This is called the Rhine Nebula. This is above the Orion Nebula, and we got some of the hydrogen alpha in it, but there's absolutely almost no oxygen. And we can see that in the hydrogen alpha is obviously much brighter. And actually, in order to produce a good image, we have to fit the image brightnesses together so that, the image isn't just dominated by the red from hydrogen alpha.
Right.
How do you
So
d Yeah?
I was going to say, since I was um, foolish enough to bring up neutrinos earlier, Fred asked, how do we differentiate neutrinos from the sun, from distant star neutrinos? And that's been a thing. In fact, we very rarely can identify specifically where the neutrinos come from. I think the one time was when supernova 1987A happened, and there was this star in the Large Magellanic Cloud that blew up, and we got neutrino events from that supernova, and that was good because we could see that the neutrinos arrived just prior to the light, as theory would have predicted. There weren't many counted, that's for sure. In fact, I think there were more papers written about the neutrinos detected than there were neutrinos detected. And so it's difficult to get an actual source unless there's an event that happens, since neutrinos largely pass through most things without being stopped. Hey, that's
Yeah.
I'm tongue-tied tonight. That's quite a difference you've got between the two images there.
So this is sulfur, and you can see hydrogen here, and they're obviously much different. First, the sulfur is fainter. That is obvious, but we can actually see the trapezium because it's fainter. So there we are. We have it right over
Right.
here. It's this one little blob here. So we don't have enough resolution. Also, it's blown out to really resolve the trapezium, but here it is. This is what's illuminating the Rhine Nebula. But the thing you want to pay attention to here is the sulfur, it tends to be where the gradients are. So these very sharp edges of the nebula, they tend to be there, and that's because that's where collisions are happening. And the astrophysics behind that is the sulfur tends to cluster around the places where there's collision events, etc. So that's why we can get this very nice contrast with the sulfur image compared to hydrogen or oxygen. Oxygen is not that contrasty. It's much more diffuse than sulfur. But now we can put these channels together to do a little bit of playing with colors. So let me bring that up and we can do
Awesome.
that. This is a more complicated palette, I have to say. So we're gonna be okay. This one didn't work. That does not look good.
So, so the vast majority of the nebulae that we see are made up of essentially just hydrogen and helium, but small percentages of other things. The nebula that produced the solar system, same way, hydrogen and helium, making up about 99% of the nebula, but small amounts of other things.
Okay.
And by using the narrowband imaging here, we can tune in directly to detect those small
Hmm.
amounts of other things, which is pretty awesome.
Okay. I don't think this palette looks good. It looks a bit magenta. We'll try a different one. This is how narrowband works. You just keep combining it until, well, narrowband astrophotography, that's how it works. You combine it until you like it. So this one is where hydrogen is green, so we can clearly see the difference between oxygen and hydrogen
Mhm.
here. So
We're almost a month too early for the St. Patrick's Day Nebula, so
yeah.
we don't really want to go with a green.
Well, how about space algae?
Well, yeah, we can see the difference, but I wonder why that palette didn't look good. We will try this one. This one might be good. So experimentation is the way. I'm not sure what that is. Okay, every time I try something, it's magenta, so we won't go with that. We can try the classic hydrogen, oxygen, oxygen, where we skip the sulfur. So that's another one we can try. The process is called pixel math because we're doing math with pixels. So this is nice, but we can see the hydrogen
Yeah,
is so dominant it combines with the blue from the oxygen to make it white. But I guess what we're mostly seeing here is the difference between hydrogen and oxygen. The sulfur is just a little too faint to really be that noticeable in this image. But also we don't even use it, so that probably helps. Yeah. But I guess while we're let me go to the next target while we're still at it.
all right. Is that going to be the horse head?
Yeah. That's really close. We're
It
testing
is
it, but
Well, also
very
in
close.
Orion, yeah.
okay, go. Okay, it'll do
Horse
its
head,
thing. It'll take its
horse
image
head
while
nebula is.
yeah,
Go ahead.
I'll be leaving it to take the images of the horse head while we're trying palettes. But yeah, you can. What were we gonna say?
Oh, I was going to say where the horse head is, but
Oh,
that's okay.
sure. Here we are. So we're
So
going
we're
from.
back to yeah.
Well, we're gonna
Go
be
ahead.
hopping over here. It's just a small hop.
Still in the constellation of Orion, and now right next to the belt, and
Um,
just a bit south of Alnitak, the easternmost or leftmost as you face Orion star in the belt of Orion.
Yeah.
yeah, we visited Alnitak just a week or two ago, I think, with our spectroscopy star party.
Yeah. I think we should see something here. Oh, there we can see his traces of flame, so it's almost
Mhm.
there. It's finding it. Meanwhile, I don't like the color of this. I'm gonna play with it a little more. We can put a little more blue in it and see how that works out. Cause I
It's
didn't really,
almost an art form.
yeah, that's astrophotography, yeah.
Some of our viewers may not realize that astronomers get into art, amateur astronomers in particular.
Well, it's what makes astrophotography an art. You have to keep playing with images. This one's funky. I think that looks okay. This
Yeah,
one
that's
is
kind
this is where we make hydrogen alpha blue and oxygen red, which is completely the opposite of what it actually is in when we see it. But it, I
of.
mean, when you're doing narrowband, you can make some really good false color images. So
Sort of maybe a 60s psychedelic Orion
yeah,
Nebula.
Mhm.
so There's a lot of different ways we can play with this image to get the colors we want. But in general, the S2 is very weak.
Mhm.
So I don't think we can do much with that on this object, but hopefully we'll see what the horse head has to offer. And as we can clearly see here, we have a moon. That's really bright.
Mhm.
Yeah.
Flooding the sky with this sunlight, reflected sunlight. Yeah.
Yeah, you
Yeah.
can see that it's exactly where the moon is coming from. It's right up there. Oh, that's
Yeah.
beautiful. Yeah, I don't know. Well, yeah, we're getting reflections from the moon, but that's okay.
Are we pointed at the nebula now?
I think it's still getting there. It's having.
Okay.
I think I'll just stop it for now. What is it
So I
doing?
see Fred in the chat says that he had an astronomy teacher that said the Horsehead Nebula looked like the Disney version of the Big Bad Wolf. I had heard that before.
I think what's happening is it was trying to meridian flip because the horse had just crossed the meridian. So I'm just gonna make it go to the rosette instead. I think so. Yeah, that's why we have to be careful on the meridian because when it detects that it's crossed it, it's gonna flip because it doesn't want to collide into itself. That's because there's a mount there to collide with. Can you assign colors manually rather than use canned colors? So, I mean, that's what I'm doing with this module here. It's basically we can put what channel we want each, the red, green, and blue to be. So I could put basically anything here depending on how I want it. And so narrowband really gives you a lot of freeway on how to use it. Okay, as we can see, we still have moon problems, but are there clouds? I think there's clouds, maybe.
I know we're all inside.
Yeah, we're all inside, so I wouldn't know.
Is the sky really out there?
Huh. That's weird.
All
Well,
right,
we might
I'm
have
gonna
to
call
try
up
something else then.
Hmm.
I'm going to call up a cloud loop from the Weather Service.
Well, that's the first. Well, we can see if by monitoring. Okay, that's not clouds. I don't know what that is.
No, I don't think clouds are an issue now.
I think that's the moon, probably messing with stuff. Okay, well, I'll try making it go there again. Yeah, it gets quite messy with this imaging with the moon. So I guess it's still trying to find the rosette now. The problem is it's very hard to find stars.
So we've officially moved to the rosette.
Okay,
or
that's.
are moving toward, I should say.
Okay, where is it right now? It says it's close to it. Well, I guess we can take an exposure and see if we have it. But meanwhile, I can show you what we can do with this right now. So let me see why this one wasn't working. This one's more complicated. So we can make this as
Now,
complicated as we want it to be. Yeah?
which ones are you putting together here?
Crazy stuff. These are very complicated expressions. But these ones are the ones that get you nice colors. So, for example, let me pull out an old. I took a test data set last night. We can pull that up and see how we can play with that. Well, this scope's trying to find the rosette. Well, it's now capturing, but right.
Okay.
So this is some data on the jellyfish. So let me close off the Orion because I don't think we need that right now. So let me first explain what channels these are. So this one's hydrogen, and hopefully you can notice that because it's the brightest. So, and this one is just this one's oxygen. And let me pull up if I'm right. I know this one's hydrogen. The other one was sulfur. So yeah, sometimes they look alike because it's the object, so it looks like the object. But usually sometimes there's color
So the
variety between them.
Jellyfish Nebula is a supernova remnant,
Yeah, it's
off in the constellation of
it's
Gemini.
it's near a very bright star called Propus. So let me show you where that is. So this is a Gemini. Here's the two twins. It's near the meridian right now, but this is so it's over here at the it's on one of the legs of the twins. So that's very unkind for a star to blow up there, but we can see what we can do with this palette now that we have it. Okay, I need to do this process first because basically it's a version of balancing the channels to make sure that they're on equal levels so we can get some color variety. So
And you shot with a wide range of filters?
yeah, this one's oxygen, very little of it. This one's sulfur, there's a little bit of it. This one's hydrogen and there's a lot of it.
Cool.
So if we do a combination, okay, I don't like those colors. I don't know why that keeps producing magenta, but it does. Huh. It could be that. But basically you keep trying out these palettes until you get the colors you want. So this one's kind of red and blue. This is what we had earlier.
Yeah, that's interesting.
Yeah.
I have literally no idea where it is relative to the nebula, but there is a neutron star that has been identified that's associated with this.
Oh, wait. Oh.
Not that I would expect us to see it, but
okay, now I know why it's.
You can get.
I figured out why it was producing magenta. You have to basically do something called stretching because when the nebula is like this, it's not very bright, but this is how we're seeing it. But we have to adjust the data so it looks more like that. So we can do that fairly quickly. We're gonna basically bring these up to levels where we can actually see the detail, and then our playing around with them will work a lot better. So there we are. Now we can
image processing on the fly.
Now we can get an image like this, and I think we got a fiery red kind of thing going on.
Yeah.
There's a very faint oxygen channel because the oxygen channel is very faint, but I think that's looking pretty good. We can do a little bit of color balancing, and that looks a lot better.
And you can definitely see where it gets that nickname of the jellyfish.
Yeah. Yeah, so that's. Then let me go back to the Rhine data because I did disservice to it. Yeah, we don't need this. Meanwhile, let me see if the telescope actually made it to the rosette. Okay, I don't think I would.
Check and see.
I don't think I would call that making. Oh, I don't think I'd call that making it to the rosette.
All
Made it to the moon glow.
Yeah, it's getting. upset. The moon's really grinding its gears right now. Okay, let me go back to the Rhine data so we can see what we can get out of that. So that one's
Excuse me.
that's hydrogen. This one's the oxygen. And
Nice.
this one's the sulfur. This was taken on the fly. So now we can do the same processing that we did to the jellyfish so we can get a nice image out of it. All right. Yeah, that takes a while. Okay, it made it here. Now let's see if it can make it to the rosette again. I feel like there's must be something in the way. The sky isn't being kind right now.
To respond to Fred in the chat, I don't know why everyone complains about the moon. He's using the name Cynthia.
Well, if it makes your
The
images
moon's a
worse,
pretty awesome thing, but yeah, it does add a lot of sky glow, of course, which is why we're trying the narrowband imaging to see if we can defeat that tonight.
this is 3 minutes of data, so keep that in mind. 3
Yeah.
minutes of narrowband data. Usually we take hours on this kind of stuff. So
Right, you'll see that in the magazines like Sky and Telescope or Astronomy Magazine, and the images at the back that people take, and sometimes the amount of time people spend on an image, the amount of time exposed to the sky is just astonishing.
all right, so I guess this looks better. We got orange and aqua kind of palette.
Well, I'm a Miami Dolphins football fan. That's almost their colors.
I mean,
they're aqua and orange.
if you don't like it, we can always try another palette. That one. This one's where we have no sulfur. Less aqua, more orange-white, so I don't really like it. I'm gonna close that one.
Yeah, more tangerine. This is a little bit more like a lime.
This one's the standard hydrogen's red, oxygen's blue, oxygen's green. So this is more close to true color, kinda.
Right, right.
It's missing the reflection nebula that really makes it even more blue, but we've got more or less the same thing from before. And this one's the SHO. This one's the Hubble Palette, so this is what Hubble typically uses on its images. Except I need to... Okay, I think I need to remove that ×2. So this one's where hydrogen's green, oxygen's blue, sulfur is red. And because sulfur is so faint... Yeah?
Yeah, I was going to say, if people can recall the famous Pillars of Creation picture, this was the same color palette that was used for that.
Yeah, and since sulfur is basically very faint in this nebula, we don't really have it showing up much, except for maybe in the core, because that's the brightest part. But yeah, I mean this one just I like the orange a little bit more, so I think I'll keep that. So I guess that's our Orion for tonight. And this is 3 minutes. Let's not forget that part. So it looks noisy, but we're only getting like 3 nanometers of light from some of these filters, so it's bound to be. Also, the moon's up. Huh.
Okay, so Fred's almost calling me a lunatic.
I didn't even tell the telescope to go to it. Wow.
Oh, so it's not there.
No, I didn't go there. I didn't click the slew to target button.
Oops.
Okay, so there is a question. Yeah, go ahead.
I wonder if they're referring to this part of it over here, this Running Man, or they're referring to M43. I guess we can talk about both. So
Sure.
this is M43. It's just basically a little extension to the Rhine Nebula. And we've got a Mission Nebula, we got some Dark Nebula going on in here. And it's cataloged as a separate object because when you look at it visually, this one's like a little fainter patch that's next to the very bright Orion. And the top part here is the Running Man Nebula. So
Right.
we only seeing the hydrogen alpha here, so that's why it looks green. Well, it looks, I mean, red because that's the palette, but there's a much more extensive structure to this if you take a full color image of it. But we're only seeing the Mission Nebula, so that's what we're seeing in this entire image. And
Right. And she was asking about M43.
yeah, did it make it? It's finally making it. But I have a strong suspicion there's clouds. Oh, we're there. It's there now. It's
Oh,
around
yeah.
here. I think there might be some high clouds that are messing with the telescope, I guess. I don't know because I'm not outside. But normally, this is a very stable setup, so it doesn't do things like this without cloud interference. But we're going to be getting some additional data soon. And this will be on the Rosette Nebula, which is... Oh, and it made it. Okay. So let's show where that is. Da, da, da. So this is in the constellation Monoceros, which is very embedded in the winter Milky Way, which you can barely see here because moon, but basically it's to the left of Orion, more to the east of Orion, and we've got some really nice emission nebula here. We got some dark nebula structures, and we've got a star cluster. So all of those should show up in our narrowband image of this target. And this one is very strong in all of the channels, so it can really produce really nice images if we can get the data on it. So we're going to see how much progress the telescope's going to be making. Okay, it started hydrogen, so we'll be getting that soon. So right now,
Right. So this is often the constellation of the unicorn, in case you were wondering.
Yeah.
I know you gave the other name. I just thought I would say what that was.
Yeah.
But what produced the Rosette Nebula? Is it a result of a?
I think it's an emission nebula. It's a star forming region. So it's like Orion.
Right. So maybe a little farther along than Orion. So we have this cluster of stars in the middle, and it's in the process of clearing out the center of the nebula as star formation has happened there. But there's still more of it going on in the surrounding rose-like area, if you will, which is why was that around the cluster.
Yeah, and I mean, also I'd like to add that it looks nice, which is, I
Which
guess,
is
the
a perfectly
defining
valid
feature.
reason to observe it.
Yeah. Okay,
Well, it has a captivating
let
form.
me get rid of the monochrome stuff here. We don't need to see that now. We're done with Orion. So far we've gotten 3 images for tonight. So we'll wait for the Rosette Nebula to show up.
This is a farther away than the Orion Nebula too. The Orion Nebula is like around 1,300 light years or so, and this is more like 5,000.
Yeah. And we can already see the star cluster in this exposure. So, and I don't know if you can see it, but it's the faint outline of the nebula. This is a 2-second luminance from San Marcos with a 50% moon. So, gotta give it a break. Okay.
2 seconds.
Yeah, the plate solving exposures, the exposures the telescope takes to find its target, those are 2 seconds.
Yeah, but you can definitely see it's the background is darker around the stars at the middle than it is where the Rosette is around it. So yeah,
that's oxygen.
Hey.
It took oxygen. Okay, I thought it was gonna take hydrogen first.
Well, it's got a good amount of oxygen then.
Well, let me tell it to take the hydrogen too. We need that. Also, the hydrogen's the most impressive, which is the phenomenon usually. So this is the oxygen, and if you've noticed, it kind of looks like some of the outer parts are missing, and that's because oxygen tends to cluster at the center of emission nebulae. So we don't, it's usually something that's more in the internal structure, while hydrogen is basically all over the nebula because it's the most abundant. The oxygen tends to be closer to the center, and what is going on with the guiding? Huh, okay, I guess you can do that. Okay, well,
We doing okay?
yeah, we're, I think it's like, probably like some wind gust or something, but we're back on track now.
Good.
Okay, just have to take these exposures now. Then we can get oxygen. Well, we already got the oxygen. I'm slipping up. Anyways, so yeah, the oxygen tends to be at the very center. The sulfur tends to be where there's collision happening, where it's very active. So it tends to be on the very contrasty, like kind of like the edges of the nebula. And the hydrogen's all over the place because it's the most abundant thing in the nebula.
In the universe as well.
Yeah.
Yeah.
Okay, so I'll open up that oxygen so you can see it. Okay, and as you can see, this little bit of it's fairly faint, which is what you get, but it really helps us isolate this nebula, because otherwise we wouldn't be able to see it. If we had a luminance filter, it'd be very hard to see it, but we can isolate these specific elements from the nebula, and also helps remove a lot of the light pollution and moon glow, though it's still there.
Mm-hmm.
Okay.
Looks like you've got some nice detail on the nebula.
Yeah, we're seeing the dark nebula structures here, so let me make that a little bit bigger
Mm-hmm.
for people. We got the structures in here. We've got the star cluster, and when the hydrogen shows up, we'll see a little bit more of that outer expanse. So, still making progress. Yeah, if you think the oxygen has nice detail, wait for the hydrogen. It's gonna be a lot more.
The tension is mounting.
Yeah. We've still got 34 seconds, so I guess we have. If there's anything else to talk about the rosette, we can do that. Well, it's if I'm another thing is it's pretty easily observable with if you have a large aperture telescope, it's fairly easy to see with some filters. And also if you hold and if you're in very dark skies like Doug is in Loretto, you can actually hold up one of these narrowband filters to your eye and you can see this nebula naked eye because it's a very strong emission nebula.
Oh, that's impressive.
But you need like very dark
I've
skies to be
never.
able to do that. You can't. I tried it in
Yeah.
Julian. I couldn't see it, but Doug is enjoying very pretty dark skies, although he can't. He's not able to find a good location to set up the telescope yet. And we've got sulfur here. So as you can
And
see, it tends to cluster very at the edges at the very high intensity collision regions, and that's why it looks like this. It's at the very periphery of the nebula.
mm-hmm.
So let's open that up so we can see it. They should sell narrowband filter glasses. Well, the thing with that is, if there's not a lot of nebula that'll be bright enough to see in that. Like we can have the rosette I said, but you have to be in very dark skies. M42 is visible with the naked eye in even light polluted skies, so it shouldn't be too hard to see with those filters. But something that people do is they put a narrowband filter and they have night vision stuff. So that's night vision astronomy. You can put a night vision uh, piece of electronics and you put a narrowband filter and you can use that to observe the sky and you can see a lot of the nebula that we typically think are very faint and you can't see with the naked eye, but they're able to put that on telescopes or with the eye and they can see these nebulae because
Hmm.
the night vision amplifier is very powerful in doing that. So people are very creative when they're trying to tease out these faint things. Okay, we got
Right.
so
And I think we may have gone there earlier, but Fred asks about the nanometers of the filters that
so
you're
the
using,
hydrogen
the band
alpha
pass.
is 5 nanometer filter, and that's because I wanted to include nitrogen because that's a line that's very close to hydrogen. So whenever I image with this filter, we get a little bit of nitrogen emission too, along with the hydrogen emission. So if you were to write
Okay.
that in a paper or something in a scientific community, you would put hydrogen alpha plus nitrogen 2 because you want to say, yeah, I'm using something that's including that line. But the
Right.
oxygen and sulfur, they're both 3 nanometers, so they're very narrow. And that helps us even better isolate the lines away from the light pollution, away from the moon glow.
Hmm.
So we've almost got our hydrogen pic image, and then we can really get to it. 20 more seconds. The tension's building, I guess.
Yeah.
Photomultiplier, yeah. That's the better term for what I was trying to talk about.
Yeah.
There we are. And that's very bright because it's hydrogen. We can see a lot of the nebula in the periphery, and we can see very bright structure. We're getting good signal on all of this. And that's typical of
Hmm.
hydrogen on most objects. So we can open that up and we can do some messing around with the image. So we can get some colorful images. So this
So what
one's, I
your field of view is probably what, about a degree and a half or so?
think it's like, I can check that right now. So
Well, I'm just curious
it's
if you happen to know it.
2.5 degrees length and 2 degrees width.
Okay.
And we're at 2 arcseconds per pixel. So this is 80 millimeter fractor at f4.8, and the sensor is Doug 1600, which is a monochrome camera. It's a little smaller than a DSLR in terms of the sensor, but it allows us to get this wider field.
Hmm.
So
That's nice because it's a fairly big nebula.
yeah,
It's nice to be able to catch it all.
and actually on another target we can even get multiple nebula in the same field of view. So that's
Hmm.
what something like wide field is very good at. You can show objects next to each other instead of just isolating them with the high focal length telescope. Okay, so now what we need to do is, because what they actually look like is this, because they're very faint. And this one also looks like that. And that one looks like this. You can barely see the nebula. So we need to do something called stretching to show it. Yeah, so 4 times the size of the moon. Well, I think it's 5 moons across and 4 moons width. So
And the moon's about 30 arc seconds, half a degree.
30 arc minutes. Yeah,
Oh, minutes. Yeah, I
yeah,
said seconds, didn't I?
yeah.
I didn't mean to do that. And of course, um, size in the sky is different from size in location, and it's also pointed out there in the chat that this we're looking at is like it's 130 light years across.
Yeah.
Thank you for that.
Well, never identified
Which is
it.
big.
Okay, because of the guiding issue, the oxygen's at a different part of the sky, so I have to align them so that we can put them together. Okay. Yeah, that's usually what happens when you have this kind of the guiding changes where the location of the telescope is. Okay, now we can do this process. So we've stretched that one. Now we can stretch this one so that we can bring it back to not being just a dark, very faint thing. Get these out of the way. Okay, where's the hydrogen? Okay, there's the hydrogen. This one's very bright.
It sure is.
Okay, now we can do the pixel stuff. That's the
The pixel stuff is the technical term, right?
Yeah. Okay. We can now get a color image out of these 3 channels, and okay, where's that? I need to do color balancing. Okay. There we are.
So what did you assign to what here?
This one's complicated. So roughly sulfur is red, roughly hydrogen. This is SHO, but with some tweaks to make it a little more interesting, basically. So this is like the Hubble Palette, but with some tweakings to make it a little more interesting. So we've got red. We can see the red from the sulfur. We can see the green and blue from the oxygen. So we can really see that color depth. But that's not the only way we can do that. We can also do this one, which is only using the hydrogen and oxygen. We'll see how that looks. Oh. Huh. Okay, wait. I didn't put this channel back. This one's out of I'm just adjusting the brightnesses for these channels. Okay. This one's a bit hydrogen dominated, so it's really, really red. So,
But that's a bit closer to reality then.
yeah, it's a little more orange than it should be. We can try the more accurate version of trying to do some color stuff. This one's closer to reality. And it's just mostly red, but we can kind of see some blue. And if we look at the stellarium image, this one's true color, so this one looks the most like it, I would say. So
Yeah,
it's still a bit different because of what we're doing. We're isolating channels. So actually, while we're still talking about this, I'll make this go to the next object since it's done. So.
And now I've lost our sense of, are we going to the cone?
Why not?
Thanks.
We don't have to. We can decide what we want to go to.
Well, what would you like to go to?
Looking
You
for.
are in command.
Actually, there's no oxygen on this target, so we'll just. Oh, I have to refresh it. Okay, we'll go to this one while we're. Well, this one will take the images while we're talking about this. Okay, so this one's closer to reality. Not quite. This is SHO. Oh boy, that looks real magenta. Okay, let's make that. Okay, I don't think having sulfur times 2 is a good idea. Try that again.
That looks fine, what you just had.
Okay, this one's closer to SHO now. So the Hubble team does make some more tweaks to it, but we've got this green and blue stuff.
It does feel like the Hubble color palette there.
Yeah. So this is just straight up SH and O, and we can see the blue contribution from the oxygen. We can see the green from the hydrogen, and where it's orange, we've got some sulfur. So this one isn't showing the SHO more strongly, but this one's hydrogen oxygen. So
okay,
let me bring this one back because I like this one the best. This one I think looks the best. Of course, opinion varies among astrophotographers.
Oh, that's for sure.
You can choose whatever palette you want. That's the beauty of it. I can make this a little more blue. So that one looks nice, I would say.
Yeah.
Okay, I'll make this one the official rosette for tonight. But you know, quite a lot of options to how you want to do it. These are all going to be false color because they're not even close to true color, this one at least. Are these Bok globules? Yeah, you typically see them in a lot of these nebula. Um, but I wouldn't really consider these dark structures to be Boks, but they are dark nebula. Actually, another tip you can do to make these less noisy is you can do something, you can use the hydrogen as a luminance, so that helps you. So basically what that's doing is that's making the brightness data linked to only one channel, which is the hydrogen, because that's the brightest one, so we can do that. And let me see if this has arrived at the cone. Okay, it's arrived, so we should get some cone data soon. But okay, that's a lot less noisy now.
So Bok globules are pretty interesting things. First identified by Bart Bok, who was an astronomer who really pushed the importance of studying our own galaxy, the Milky Way, in a way that people hadn't before. In fact, he wrote a classic book with his wife, Priscilla, book on the Milky Way galaxy. I had a chance to go to a talk by him when I was in high school a million years ago. Um, Pretty interesting stuff. But Bok globules are definitely locations where star formation is happening. Hey, but we're off to the cone now.
It's showing up in 20 seconds, so I guess we can I guess we can, people can enjoy this while we're still waiting for the cone. But
So we're still in the constellation of the
we didn't go
unicorn,
very far. That's
Arcturus.
true. If you
Yeah,
see there,
it's
Rosette's
in
over
the
there,
neighborhood.
Rosette's over here, cone's over here, and we've just made a small little
Yeah,
hop.
which near the famous Christmas tree cluster,
Yep,
which is kind of what the Cone Nebula is pointing toward.
and there we are.
Yeah. Both together.
And we're gonna take some sulfur and see if anything shows up. So this is fairly faint, so hopefully we can get some good data on it. Okay, let me open up that hydrogen. If the hydrogen's faint, then you know everything else is gonna be real faint, usually. But yeah, we can clearly see there's a cone over here. It is cone shaped, so that's good. Move the other images
Jeannie
aside.
has shared her favorite Bok globulas. I see
Okay, where is that?
2944, and I don't
Oh, the
remember what
running
that
chicken. This
is.
one's a southern hemisphere one. I think she's referring to this one, I guess. But yeah, that's southern, so I don't like it. Way too south. This is approximately right now. This is 27 degrees above the horizon right now. No, 25.
You mean below?
Yeah, below.
Yeah.
Okay.
But it's a cool one.
Let's go back to where
You
we
just
were.
can't see it from here.
There's the cone. And where's the sulfur now? Okay, we're still a bit away from the sulfur now. ESO has an amazing image of a download. Yeah, it's a pretty bright target. It's really easy for astrophotographers to image, and you can get really good, nice detail. I think it looks best when you take it in true color because there's a lot of other components to it, so not necessarily narrowband object, though you could, because since it is pink and there's hydrogen there, because so that tells you that there's hydrogen there.
Cool.
And another reason why we don't necessarily get true color when we do narrowband is because there's not only just one line of hydrogen. There's hydrogen alpha, which is definitely probably the most high intensity one, but there's also hydrogen beta, which is 486 nanometers, which isn't too far from oxygen. So it's more of a bluish line, but that helps definitely make a lot of these nebula look more pink than red.
Right.
We gotta talk Anasi into doing Star Party. Well, good luck with find one and we can do it. Okay, I think we got sulfur here. Did it? Yeah. Very faint, but it's there.
Oh yeah.
Okay, yeah, it does look like we have something. So that's good. So let's do this process.
Does
Oh,
Does Julian have a sister city in dark skies? Someone we could connect
sure-
with in the southern
I'm sure the
hemisphere?
closest thing we have to that is Loretto.
Well, I'll do the best I can.
Yeah, we need to connect with someone in Chile or Australia or New Zealand or something like that.
That would
Yeah,
be
there's
great.
a lot of targets down there to image. Some of them barely show up for us. I mean, the Rhine Nebula is technically a southern object, I guess.
Yeah, but not by much. I mean,
Yeah.
you're not going to see it from the Arctic Circle. Well, actually,
Depends on how close to the North Pole you are.
right. From the North Pole, no.
Okay. Very faint. Faint, but not that faint.
Mm-hmm.
Okay, well, there's gonna be a lot of noise, so we're gonna try it anyways. Meanwhile, I'll make this telescope go to the next object. So, which one should that be? Monkey head? Okay, do that. That one looks real nice. Okay, we're gonna head to the monkey head. Well, the telescope will be figuring out what to do with this cone nebula. So we've got the hydrogen, we got the sulfur, and let's play with it. So let's do the.
So that's.
We'll
Go ahead.
We're gonna make the HAS2S2 palette again. See if that looks any better than it was before. Okay, well it went as predicted. We just see a lot of red. That's a lot of red. Yeah, just a lot of
Yeah.
red.
It is.
Yeah, this is
Except
too
for the
faint
actual
to
cone
be
part.
anything but this to do any color contribution. It's just too faint for that. So we're just gonna enjoy our red cone nebula, like here. Very noisy because it is a very faint object, but we're able to get in 3 minutes, which is quite a achievement. But if it
I would
wasn't for
agree.
narrowband, so that's the power of narrowband. You can get these things real quick, but it doesn't have to be necessarily bright.
Yeah, with a first quarter moon.
Yeah, it's first quarter. It's actually near all of these objects. Like, let's see where the moon is right now. So one of the targets we're supposed to do for tonight is right there. Four of them are right here, and the moon's just I think 12 degrees away. So that'll be a really fun object to image, I would say. We'll see what we can do with that. But are we making progress? Oh, jeez. The moon's at it again. Okay, so actually, let's see where the monkey head is, so we can see.
It's in Orion.
Yeah, it's over
Yeah.
here. It's at the club part of Orion. It's very close. It's very close to the jellyfish, which is the object we were looking at before. So it's just not very short hop away, but very close to the moon. Actually, yeah, that's like probably 20 or 20 degrees away. But let's see what we can get out of this one. Yes, this is the cone for tonight. So if there's not much else we can play with it when we don't have oxygen. At least a palette that looks good. But there's a lot of other nebula. We got some dark nebula going on here too. Yeah, so the monkey has just another typical emission nebula, but we've got some interesting structure over here. And this region over here was actually a part of one of the Hubble's photographs. So it imaged just this little portion of the monkey head. So when you Google that nebula, usually what you show up is just a picture of only this portion.
Which doesn't look anything like a monkey's head
But
when you only see that.
yeah, we actually looked at this with broadband in like the star party that was a month ago. So that was when we imaged it with broadband, it was just red because hydrogen alpha dominated. So with narrowband, we can actually look at the other channels and make some more color variety than just having it be red. Unlike the cone, where we have made it just red. Okay.
So my astronomy app here tells us that the monkey head is just 15 degrees from the moon right now.
That's fun. So that's a real treat.
And by treat, you mean the opposite.
Yeah, well, we got this awesome gradient here. You can clearly tell that the moon is roughly to the right of where the telescope is right now. So,
yeah.
8 seconds, and we're about to get our hydrogen alpha. So this will be the brightest channel. And
hopefully that'll come through and look nice.
Well, it's gonna be to the narrowband. And there we are.
Oh, there we go.
Also, we're featuring dust from the courtesy of the moon's glow. We got a dust mote here.
So one of the things the professionals do every night is what's called flat fielding. And you take a picture of an evenly illuminated screen or the twilight sky and basically saturate your camera so that you can find things like that are in your dust on the filter or dust on the camera sensor or something like that, so that you can correct for that when you do your actual science on your images.
Well, astrophotographers do that too, and what you do is what you do is you take the flats and then you make a master flat. You do the same kind of stacking you do with the lights, and you divide that from the image so that this decimal goes. Now the problem is here is you usually take the flats. You have to take the flats at roughly the same time that the images are being taken. So you have to take it on the same night with the same train, so that these sneaky little decimals don't move. Otherwise, they're problematic. But flats become even bigger issue in light pollution, because when you have things like the moon, for example, doing this to the image, those things show up they show up really sharp and they really show up in your images even more than they would if there was no moon. So they become really annoying.
And the reason I said that professionals do this was so nobody thought, well, why weren't you doing that? But I realized
we're not doing it. We're not doing it because I didn't usually when I take flats, you do it after you're done imaging, and we're not done with it. So
I'm not.
Yeah.
I know, and I'm not trying to slam you.
I know. I get it.
And everyone that's serious about trying to produce really good imagery will get into that at some point, professional or amateur. And I'm sure that's something that you've done. But for our purposes right now, it's not necessarily a thing that we need to worry about.
Because if you just do this, they go away, right?
Yeah.
Actually, you
You
don't
know,
want to do
dust in
this.
space is so much more interesting than dust on your camera.
Yeah. Actually, let me. Okay, that's the hydrogen. We should have gotten our oxygen in 7 seconds. So that'll be fun.
But
But
again, the background from the moon is an annoyance, but the fact that we're just 15 degrees from the moon and we've got anything, I think is pretty impressive.
yeah, that's where the 3 nanometers really matters, because
Mhm.
without that, you would not get anything. I mean, like anything at all. You would just see white. With these such a long exposure, you'd see white. Actually, this one looks. I mean, the only reason that we see anything here, it's not just pitch black, is because the moon's really illuminating it brightly. But anyways, let me get this ready. This one's the oxygen. So while we're waiting for the S2, we can actually just uh we can see how it looks in HOO, which is the palette with that looks the most realistic, and we should just see a bunch of red with that. So this one, yeah, this one's HOO. Okay, let's make that. We'll see our fun, exciting moon image. Okay. Oh boy, the moon's really doing some stuff, isn't it? Okay, so as expected, red.
Hmm.
Although we can see that there's a bit of white in the center because um, we've got that oxygen in the image too. So we're seeing like a gradient from red to white because of that oxygen. But in general, it's mostly hydrogen dominated. But we can make it a little more interesting once we get the sulfur 2 in here. Uh, and actually, the stellarium image this time this one's a Hubble Palette image. So what we should get is roughly close to what this should be. Once we get it at least. But yeah, if you're in light pollution, taking flats is extremely important, or else you're gonna get sneaky little dust motes all over your image, and you're gonna get, well, this. This doesn't look particularly good, I would say. This background.
Yeah.
Actually, there's something we can do about that. Let's see if this thing works.
What are you trying?
This one's it's called background extraction. It's an attempt to correct the background. So it identifies what the background looks like and it can try to
Oh,
correct
okay.
it. And it's automatic. There's a manual one, and that one's usually what people use, but I'm
Sure.
not going to bother with that right now.
Sure.
Okay. So that's our fun HOO image. So not to be confused with the Christmas palette or the Ho. Who? And we got our
Excellent, Todd.
sulfur. So let's make it go to a different target now. We have a lot of choices. Do you want
So where did you want to go?
do you think we should head to the tadpoles near
Well,
the moon?
that's further away from the moon.
It's further?
So that's okay.
I thought it's
I
closer.
think
Oh, I think it's
closer to the
roughly the
moon.
same distance. Oh no, it's okay. Yeah, it's roughly the same distance. So we'll have some more fun with the moon, I guess. But it's got a really nice structure to that, so I don't have this one saved, so I'm just gonna manually put the coordinates in here. So that's 5 hours, 22 minutes, and 59 seconds. These are coordinates. These are how we get anywhere across the sky. So
Right.
33 degrees north, so that shows us it's the northern hemisphere. 24 arc minutes, 3 seconds. And that's derived from this fun little equatorial grid of the sky. So, and this one actually is, yeah, it's very close to the moon. It's literally just the same distance.
Oh my gosh, yeah, it's 11 degrees from the moon.
Oh,
Sorry.
even closer. That's
Yeah,
that sounds lovely. Let's go there.
yeah. So those coordinates were in what we call right ascension and declination.
Yep.
Declination is just like latitude in the sky, only it's plus and minus instead of north and south.
Also, our moon gradient even got even better here, so we'll have fun.
Yeah.
Okay, sulfur.
And yeah, so declination is the north south, and right ascension is essentially east west. But instead of like longitude on the Earth, which goes from 0 to 180, this goes from 0 to 24. So it's measured in hours, and goes all the way around the sky.
To to be honest, I was expecting the moon to be less, uh, a little less.
Less of a bother.
Yeah, but I guess it is. The moon decides what it wants to be. All right, let's try that palette now. All right.
So this is the tadpole, right?
We that we're going to the telescope's imaging? Yeah, I think
Yeah.
it's arrived now. And yeah, you can see the moon right here. Beautiful. We'll do our best. We'll see how this contributes to the image. Okay, let's let's do some math. Okay, let's make a. So this one's HOO. We'll see how the our version of the complicated version of SHO works. Okay, so that looks close. Okay, I think that looks, but that looks very similar to the Stellarium one because actually, let me go back to the monkey head. It looks very close to the Stellarium one because this is basically the same palette. So we're seeing
Hmm.
the nice orange with the where the sulfur is, we're seeing the blue where the oxygen is, and hydrogen is all over the place. But let me try this one. Let's see what fun we can have with this. Okay, this one's just orange, so not particularly exciting. Okay, let's try true SHO, the one without the tweaks. Okay, now it looks green. So
It
what
does
this
indeed.
basically we've done here is make the sulfur a little bit stronger so that we can see it. But here, since the sulfur is really faint, it's not really there. But we can see the hydrogen and the oxygen very strongly. So I think I'll pick this one. So this is our monkey head for tonight with a very nice contribution
Yeah.
from the moon. I guess we can, yeah. Actually, we can try that trick of making it less noisy we use by making the brightness tied to hydrogen, which is basically called luminance combination. So this also makes it desaturated, so that's a problem. Let's boost the saturation. Yeah, there's a color. Okay, I think I'll call this the final image.
Yeah.
I'm sure
All right.
Doug has been doing a lot of narrowband imaging over the summer, so I'm sure he's has a lot to contribute about it.
Well, I was able to use a relatively inexpensive telescope to get
Yeah, yeah, that's
like
something I
imagery.
didn't mention. You don't need it. You don't have to use like if you know about the problem with refractors, they tend to have something called chromatic aberration where the color is out of focus between red, green, and blue because it can't properly focus them together. But with narrowband, since you're only imaging 3 nanometers at a time, you don't have to use something that's corrected. You can use a straight up uncorrected achromat, and you can get good images with narrowband because you're not imaging the entire spectrum. And that's what I'm sure you were doing with the telescope you used.
Yeah, it was an achromat, actually. It was, a pretty well-made one,
Yeah,
but still it had the chromatic aberration, which means that if you just shot it with a color camera, the stars would be blue on one side and yellow on the other. They wouldn't look very good. Um, so instead of having the distorted color flaring with a narrow band, boom, sharp stars, and able to, with the three filters, get to a pretty interesting color in the image in the final images.
yeah. I don't think the seeing is that great tonight, so we're not getting the full resolution that narrowband's capable of, but I think we're doing pretty good for the pretty meh conditions we're in right now. It's not amazing, but oh yeah, the moon glow is definitely showing up here too.
Hmm.
Guess that's what we get for being 11 degrees away. But yeah, we can see the tadpoles here. So the tadpoles refers to these two things. These are two structures. They're like the pillars. There's a proper name for them. I'm forgetting what it is, but it's think well
What's
they're
that?
called elephant trunks. So
Oh,
or
right.
the official name is cold molecular pillars. But these are the structures that we see in the pillars of creation. That's a very famous example with that Hubble photograph, which is an S-show narrowband. And what we're seeing here is the same thing, but these are called the tadpoles. So they look like two little tadpoles in the nebula. And now that we've taken oxygen, they've disappeared, but that's fine. All right, let's see where. That's oxygen. We finished that. Where's the hydrogen? Okay, this one's the hydrogen, I think. So we don't need this anymore. Okay, geez, we made a lot of images tonight.
That's
Okay,
for sure.
so let's get started with the processing. The sulfur should be showing up soon. Let's see how resistant to the moon it is. Okay, it looks a little bit out of focus. So another thing that happens during the night is because of changing temperature,
Right.
telescopes can lose focus. So it seems it has, but I'm not gonna bother. It doesn't make a difference for what we're doing. The hydrogen looks in focus though, so that's fine. Okay, we should be getting our sulfur soon.
So yeah, as the temperature goes down, things expand and contract with temperature changes, and that changes the distance between optical elements or between the camera and the focal plane. And yeah, during the night, that's the thing you got to do.
Yeah,
Refocus if you're
yeah,
wanting to get everything perfect.
typically people either refocus manually. But a lot of people use autofocusers, and I have one, but I didn't put it on. So, but anyways, it takes a little bit it has to basically what it does is it racks the focus over different positions to do make a parabola or a hyperbola fit, and then it chooses the position where it's most in focus, and then it sets it to that, and it can do that
Oh,
process whenever you tell it to. So, but I didn't connect it, so didn't happen. It's not gonna happen tonight. Sulfur looks a bit better though, so we're gonna now load that in.
All right.
Hopefully that is a sulfur. Or is it not done? No, it's not done. This is oxygen. Never mind. It's hard
Okay.
to tell them apart when they're both faint.
That makes good sense.
Again, the brightest part of this image is indeed the moon. Oh yeah,
Yep.
that looks nice. That's a nice lunar nebula. You can barely see anything in sulfur. Guess maybe it might be restricted to doing some HOO, or we could see if we can do anything with the sulfur image. Yeah, it's not even there. Ain't that nice? I guess this is what you get
How,
for imaging 11 degrees from the moon.
yeah, I guess that's correct. How's your sky in the north?
I have a house to the north.
Okay, that explains a few things.
Well, I mean, I don't think there's a lot to image in the north right now because,
The owl would be okay.
well, the owl might be like a few pixels.
Oh, that's true. Our field of view is pretty wide here, so never
Yeah,
mind.
it might be a few pixels. It'd be definitely a great object, but it's, yeah, there's gonna be a house to the north, so I can't do that right now.
No, of course not.
Also, demolishing it for tonight, just demolish it for tonight. I'm sure that will work.
Oh my gosh! So in the chat, Fred says that he found a job in Buenos Aires, and he posed the question about a simulcast. Let's see if they respond.
We'll see if reaching out. Okay, we're gonna see if this SHO looks like anything. The Lunar Nebula is definitely there. Okay, well
Yep,
we're
sure
starting. We
is.
see something here. It's definitely something here. Okay, so among all of the faint stuff we're seeing, we can definitely see the tadpoles. So these two little items
Right,
over here.
right there.
Let me blow that up for people. So we've got these are two structures similar to the Eagle Nebula, except they're quite a bit smaller. And usually you want to image these with the large focal length, like 1,000 millimeters, and you want to image them in really um, high resolution. But we're using wide field for tonight, so that's not gonna happen. But at the end, I might be able to show you what proper imaging can look like with if you take very long exposures. Okay, wait.
Was that you typing?
Okay.
Well, I think we appreciate the outreach, Fred. But
I tried chili
I'll let
first.
Doug comment on that for sure.
Okay. Well, we're at it. We can sneak a little bit closer to the moon. Well, actually, no, let's not do that.
Closer.
We can go on to let's see what we have here. What we could possibly image. Uh,
Well, Thor's helmet is at least further south,
oh
so
yeah,
there's that.
forgot about that one. Let's image that. That's gonna be really nice to look at. We can also do the seagull after. Actually, we can do the seagull first. I think that might be better. That one looks really nice. Okay, so all I have to do is just load the coordinates in here. So let's put in 7 hours, 5 minutes, and 53 seconds. So this is basically where it is in the sky relative to east and west. But this is very far south, at least for us. So this is negative 10 degrees. So it's 10 degrees below the celestial equator. 55 arc minutes. Oh, and then 16 arc seconds. So now I can tell the telescope to go here and take some images. And it'll do that while we're doing this.
It's moderately high in the sky, though.
Yeah, it's
Well,
definitely
you know,
imageable, I would
45
say.
degrees or so. Yeah.
Okay. Okay, I think this is as much as we can get on the tadpoles. Actually, that looks a bit
Probably
nicer.
so.
Yeah. So what happens when you image too close? Okay, I can do this now. This is that technique before for a little bit less noise. See if that worked. Okay, I can't really tell if that worked, but we're gonna call it there. So this is our tadpoles for tonight, and we'll file that away. And the
So we're off.
Lunar Nebula is showing up real strong. Yeah,
Yeah, and we're off to the Seagull.
yeah. I think it's. Let me see if it got. It's gotten there. It's gonna start now, and we should be able to get some data on that. So meanwhile, I wanted to show what is possible if you actually take a lot of data. So I'm gonna show you some images with narrowband. So this one is, I think, like 30 hours of narrowband with a much higher focal length telescope than what we're using. And
And the moon wasn't right next to it. Also,
that is true. It was new moon, so I didn't have to deal with that. But it was taken from San Marcos, so it still counts.
sure. That's really nice.
Oh, we don't need that. Yeah, so this is SHO but with tweaks, similar to this palette. And yeah, so that's the power that Narrowband can do. If this is taken from San Marcos, took a lot of data, got some good resolution because the seeing was pretty good, and that's what you can do with these filters.
Yeah, very impressive.
So let me see if it's okay. It's taking hydrogen now. So actually, for more context, monkey head, and I have data on this one too,
Okay.
so we can show that. Uh, this is very old, so my processing is very old on this one too. Good enough. This one, also with the higher focal length telescope, and
Now, when you say very old, how long ago did you do this?
geez, how old is this one?
About.
2019. No, this is, yeah, 2019. It's 2 years old.
Okay. Okay.
This is over here is the part that Hubble imaged.
Mm-hmm.
And you can tell this is when I had no autofocus, so it's less resolution than I usually can get. But yeah, this is SHO, so you can see you can see the green from hydrogen. You can see where it's orange, there's a contribution from sulfur too. The blue at the very center, that's due to oxygen. So like before, the oxygen wants to concentrate at the center. Same with the Orion Nebula, same with the Rosette. So,
Mm-hmm.
okay, we're
I,
almost,
I think
yeah.
in the chat we're organizing a post-COVID field trip to the southern hemisphere,
I'm
which
down.
I would be down with.
Yeah.
Definitely gonna cost some money though, wouldn't it?
Group rate.
That's true.
Group rate, sure.
There we
We
are.
just might have more. Ah,
Nice. I like this. Okay, yeah, this is a really nice target. Unfortunately, the framing's not particularly good, but I mean, the nebula itself is showing really nicely. So
from
let's,
an artistic standpoint,
yeah, I would like it to be a little, because we're chopping off a lot of nebula. So if it was rotated like 90 degrees, we could see more, but
it
it's good for
yeah,
now.
it's a big nebula.
Yeah. without me.
Well, I'm still okay with this this post-COVID tour. I mean, I've never seen the large, small Magellanic Clouds,
I haven't seen an ounce of the southern hemisphere besides,
Tarantula Nebula. Yeah,
haven't seen anything besides what we've already can see from here.
right.
Yeah, we're just here in Loretto, 26 degrees, a little
So he
further
sees a
south.
little bit more.
Yeah,
It's also much darker there if you get out of town.
yeah. That's
So
the
you get
that's
a much better view of things like Omega Centauri and during the right time of year. Maybe not right
I
now,
don't
but
I'm not sure if he's tried that yet.
I've seen it. I've seen it from here, but it's
Yeah,
low in
yeah,
the sky.
yeah.
Um,
It's
low.
it's still pretty bright, so you can see a lot of detail in it, even if it's like only a few degrees above the horizon. You can also see
yeah,
the Centaurus A, which is a really nice galaxy. You can
yeah, it's a pretty fantastic galaxy.
The Sculptor galaxy is also it reaches like 30 degrees. So okay, this one's still taking a while. We'll wait for it.
So we'll just compile this master list of cool things we can't easily see from here. And
Yeah, at this point we're just making a list of stuff to. Okay, if that's in pesos, how much is that in dollars? Fred just gave the price. I don't know what the conversion is.
I don't either.
It's like, is it 20 to 1 or something?
I have no idea.
Do you know, Doug?
What's that?
The conversion from pesos to dollars.
Yeah, about 20 to 1
Okay, so that's like
to a dollar.
$925? Is that what you're saying, Fred?
Well, how far to the southern hemisphere does that take you?
Buenos Aires.
Oh, okay. Then you just have to get out of town. And,
Or just buy some remote observatory space in Chile.
yeah. Just, well, I want to stare up at the sky with my eyes and see some of these
Yeah,
things too.
that can't get beat.
I've seen the Southern Cross from Hawaii, and I've seen Alpha Centauri from Hawaii, which I was pleased with. But in terms of being in an environment that was good to see the sky, the Big Island is the farthest south I've been.
Okay, we got our oxygen. There is something there, I can say that. So we can see like this. And as you can see, unlike hydrogen alpha, it's more lumpy. It's just a big lump in space. If you can see that. I guess I'll
Mhm.
bring that out more when we open it up in PixInsight.
I got to tell you, the chat is more focused on going to the southern hemisphere.
Is that the lesson from this star party? All the good stuff's in the southern hemisphere?
Well,
They're not wrong.
you created the appetite,
It's our fault now.
weakened the appetite maybe.
I if there's actually the I don't know if it's I forgot if it's a large or small Magellanic Cloud, but one of them's just chock full of supernova remnants. Okay, it's a large one. It has,
Yeah, the LMC.
and someone took like I like I think like 1,000 hours or something of narrowband on the LMC, and they got a really nice image in I think SHO, the Hubble Palette, and they could see all of the different nebulae, the supernovae remnants, all of that was in the image, and that was super cool. So if you want to, if anyone wants to Google that, they can. It's a really nice image. It was like a collaboration of a lot of people to get that image, because
Hmm.
taking 1,000 hours isn't a trivial task.
And where do you find that?
I'm pretty sure. I think it was a bunch of amateurs. I think if you Google the image LMC SHO, I think it'll show up.
Mhm.
It sounds like Fred had an amazing experience seeing the night sky on an aircraft carrier. That's pretty impressive. And I do feel for you, Todd. He lives in Saskatchewan, and it's been minus 47 there lately. So,
Well,
yeah.
Oh,
I'll bet
okay.
you still. Jeez.
Okay.
So, what do we got there?
Well, we're getting our sulfur now. Okay, we can see some stuff in the sulfur, so this should make a nice
Sure
image.
can. Yeah.
The oxygen is very faint, though. Look at it. Did I name it? Yeah, okay, I named it. So let's get our
Yeah. Just
sulfur.
to tell another dark sky story, to try to compete with Fred, I was staying in the middle of nowhere on the Big Island once, and still on mainland time. So when I got there, I woke up really early because I was on the wrong time. But I went outside and just sat out. We were near the ocean, and I could see stars all the way down to the horizon. And it was one of those times when Venus was in the morning sky. And when Venus rose, I could see that it got brighter out from just Venus rising. I mean, I could see the shadow of Venus. Um, it was pretty impressive. But yes, I believe we are still on the Seagull. That's correct, right?
Yeah. This is we got our our images. So now we can move on to the I forgot. Yeah, Thor's helmet. It's fairly small, but I'm sure we can get something out of it. So that one it's relatively nearby. 7 hours, 18 minutes, 30 seconds, and negative 13 degrees, so that's still very south. 13,
Yeah.
40 seconds, go now. Okay, it's heading off. And meanwhile, we'll look at this. So,
Put these together.
yeah, we got a very faint oxygen channel, but it's there, so that counts for something.
I'll say back to Jeannie, seeing those dark skies like that, very vivid in my memory. So let's see how well the Seagull flies here.
Probably not very well in oxygen. Very little oxygen on this one. We got some sulfur. I think for some people it might be weird that sulfur is an important element in terms of looking at these nebulae. But it's true.
Wow.
And this is which one? Is this a sulfur now?
This is hydrogen, this is oxygen, that's sulfur.
Okay.
And it's there, so that counts for something.
Indeed.
Okay, combining time, and we've got ourselves a very orange blue. There's not a lot of blue, but it's seagulls flying. I can say that.
Mm-hmm.
So we've got our. This is the seagull, and it's another emission nebulae, but we've got some little less oxygen, so that's a bit fainter. But if we went for more integration, we could get that oxygen to show up nicely.
That's still nice, though. To answer Fred's question, no, I didn't, but I'm getting the impression that you kind of felt like maybe they were that way. I didn't get a sense of 3D-ness, but maybe I was just too tired since I was waking up kind of early. But it was just a pretty impressive sight, and I like your color version there.
Well, I'm sure it could use a little more saturation, wouldn't you think?
Well, that's okay.
There we are.
Yeah.
You're moving down.
I mean, under the circumstances, I think that's pretty good.
Okay, so we'll make that our final seagull. And yeah, we can see a lot of structure here. There's some fainter stuff that also out there. And now that we're farther from the moon, we're free from its terror. Like, so we got a cleaner image out of
That's
this
cool.
one than any other.
How
Yeah.
far is that from the moon?
How far? It's
Um,
far, I would say. Actually, I haven't even shown where it is. I should do that. Let me show you guys where it is. So, this is Orion, so this is where we've been a lot of the time. Monoceros, the unicorn, and the winter Milky Way. But below that is Canis Major, and this one is
Okay.
supposed to look. This one looks like a dog. So
it does.
at its head, the very top of its head, lies the Seagull Nebula, and that's what we were imaging. And now we've moved
Okay.
on to Thor's helmet, at least the scope has,
Right.
and it's right
And
adjacent. Yeah.
according to my Sky Safari app, the Seagull was 44 degrees from the moon, so we were
Oh,
pretty far
yeah.
from there.
Safely removed.
Okay, I found the LMC image, so I can show that now.
Oh.
So, connecting. Okay, this one.
Oh yeah,
CL is, yeah, this one's 1060 hours, and there's crazy amount of detail.
Mm-hmm.
Yeah, we got a lot of, this is SHO, so similar palette, and there's just a crazy amount of detail on this, so that's cool. Anyways, our Thor's helmet's shown up. There it is in hydrogen alpha. Uh,
sure enough.
it's there, and it is shaped like, uh, it's got the horns and it's got the helmet, so it looks pretty similar. But we should be getting oxygen, and on this target, oxygen is brighter, so that should be
Yeah,
a little bit better.
usually.
So actually, we don't need this anymore.
So this is like a bubble of gas that's being blown off a star that
Yeah,
is a huge, massive star that's a
it's
likely supernova candidate
it's a
at some point. It's
a
a
Wolf.
Wolf-Rayet
Yeah,
star.
and that
Yeah,
we've looked at those with spectroscopy before, and that's the one with very big emission lines because it's a very hot, very massive stars.
right.
So, and this one is expelling gas, and we're going to be able to see that with narrowband because there's hydrogen there, there's oxygen there, there's sulfur in there. It's
It's go ahead.
there's also going to be other elements here, and we can actually see their emission lines. But generally, these three elements are the ones that are the most brightest, and that's why most astrophotography and narrowband are taken with these filters. But people also have nitrogen filters, so they completely isolate the nitrogen from the hydrogen. They also have helium, so you can make a lot of crazy different narrowband filters, but typically those are just going to be faint or they don't show much photographic structure that looks nice in an image. But they're they're definitely useful for science and other things. Yeah, it is spectacular. 1060 hours. I don't even know how many days of data is that. It's got to be like 50
Days,
days or something.
24-hour days, or more.
Yeah,
More
what's
than
1060 divided by 24? That's
44.166.
44.1 days of imaging the night sky LMC. So, and that's 3 different channels, so that's like 10 days a channel if they did it equitably, which a lot of the time astrophotographers don't do it equally. But yeah, that's a lot of data. But it
It sure
shows.
is.
It definitely shows in the image that it's a crap ton of data. Okay, we've got our hydrogen and oxygen, so we can do some messing with
Eh,
those.
And the other question is it the star that's in the middle of the bubble there that is the massive star? And the answer is I think so.
We can consult Stellarium. It'll definitely tell us. Okay, they're just not telling us. I'm sure it is. Let me see if it is. So that's HIP 35378. That's its name. Yes, that is the one. Okay. So out of focus on oxygen seems to be out of focus right now. But the hydrogen shows it. Yeah, there we go. That's the star that's expelling all of this gas. And that's
Right.
hydrogen, that's oxygen. So let's
So these big massive stars, this one's like 16 times the mass of the sun. They're unstable even before they get ready to supernova, and they eject matter out. And it's the kind of thing that in the Eta Carina, another southern hemisphere object, but you've probably seen Hubble photos of that with these two big lobes of gas being ejected from this thing. This is a similar kind of object. It's a seriously hot star. In Kelvin, the sun is like almost 6,000, and this is 112,000 Kelvin. That's kind of intense.
Okay, we've got our hydrogen and oxygen, so we can play with those.
Now, Thor's helmet is sometimes also called the.
There's a lot of. Okay. Really magenta. Okay, good.
Yes, I agree. The universe is endlessly fascinating. No question about it.
So we've got definitely. Actually, I want to rotate this. This isn't a good rotation. That's better. Now we
To
see
be
the
more
helmet.
helmet-like.
Yep.
Yeah, sure.
And now we can see, if you look very carefully, it's just a little bit of stretch. Oxygen's at this, mostly in the helmet, but we can see like red periphery. So the hydrogen's more in the periphery of this, and that's going again back to the fact that oxygen tends to be at the center, hydrogen tends to be outward. And so, actually, let me see if
See,
it
I get.
buffers. Oh,
I guess I can kind of see the duck there. I mean, if it's a duck in flight,
huh?
but the wings of the helmet are the wings of a flying duck.
Okay, I don't. It's a big stretch. But okay, this is our sulfur.
Right,
Very,
because the Crab Nebula looks just like a crab.
yeah. I mean, you can thank Lord Ross. That's the guy who named the thing.
Yeah, I mean
He's
they're all pretty poorly named. I mean, except for where we started with
so
the
this is our
California Nebula.
incredible sulfur image. It's basically like it's just in the horns. These are just horns here. But that's fine. I think this is gonna be our last narrowband image for the night, so
Yeah, we've been on for like 2 hours here.
yep.
And we still have a few people watching, so thank you to our
It's
loyal
not that
viewers.
it's still 9 o'clock, so it's not horrible like we've had it before.
Yeah.
But
Well,
one last pixel math. So I'm gonna tell the telescope to take a break. It can have. So basically I'm stowing it away. But let's do this combination. So we've got our hydrogen and oxygen here, but we can try the interesting sulfur addition in the horns. Oh, I didn't name it sulfur. To name it. Okay, gave it a name. So now it'll do my bidding. Okay, so that's interesting. I have to rotate it so the horns, so it looks like the helmet.
Mm-hmm.
All right,
Mhm.
that's our
Okay.
SHO. I think there's a little bit of contribution from the sulfur, but it's not terribly there. So we've got two different images. I think I think both look good though. But
And unlike the other nebulae that we've seen tonight, this one is not really amazingly red.
Yeah.
Um, and
It's
it's
got more oxygen. The oxygen's brighter than the hydrogen on this one.
right. And so the color here is
Makes it look different.
Okay,
but that looks good.
here's a real image with the more like I think 20 to
A
30
real
hours.
image.
Yeah, I mean compared to this, but with the high resolution and so
Did you shoot that?
yeah,
That's great.
this
Yeah.
is this is what happens when you take way more hours, so you can see a lot more stuff. But
Yeah.
yeah, but this is 9 minutes versus like 20 hours, so pretty good.
Right.
And this was the other one was also taken in San Marcos. Yeah. So
Impressive.
yeah, I'll I guess I'll this one's our Thor's helmet for tonight. So to wrap up, I'll just show everything we've taken tonight, and then we should. Oh, I can't use there. Okay. So let's clear everything out of the way. Yeah, don't need that. Don't need that. Don't need that. Don't need that.
So the moon is always this big challenge in astrophotography, and while it gave us some challenges tonight, we've definitely shown that we can get some decent results out of that.
Yep. Gotta get
Yeah,
the thumbnail here.
But also,
yeah, I can see that far now.
That's a really important thing too. That there are ways to image and get pretty pleasing images with narrowband.
Yeah.
Right, even in the face of light pollution.
There are people who do imaging in places like Tokyo and New York City.
Yeah, this is how you do it. It's how you make it workable.
Right.
Unfortunately, a lot of people don't have access to a dark sky.
Other thing is, the flip side of these filters is that they can be expensive. So, typically when people start with this kind of thing, they use something called a dual band, which allows hydrogen and oxygen, and that's probably like $100 or something. I don't know what the exact price is, but that's one of the easiest ways to go with imaging. So, yeah, gotta get almost done with this.
Good filters are expensive.
Huh?
I say good filters are expensive.
Okay, well, the ones we used tonight are definitely so, because they're 3 nanometers. The more you cut off the light pollution, the more expensive they get. So that's the problem.
But that's a good gallery from tonight.
Yeah.
Yeah.
It's what we accomplished tonight, even with the darn moon.
Yes, this was a defiant star party.
Yeah, I mean, I kind of planned it to be around here, around this time of the moon anyways. Yeah, so we got a good gallery here. So we're gonna end on this. Yeah.
Okay, well, hey, Scott and Vivek, thank you very much for putting this on. And to our viewers, if this is your first, you can subscribe to our channel, Curiosity Peak Observatory, and you will get notified every time we do a broadcast. So, keep checking in, and also check out the Julian Dark Sky Network website for information about Julian and astronomy, and also about preserving our dark skies where we still have them, and maybe reclaiming some dark skies where we've lost them, because all these things are out there. It's just that light pollution prevents you from seeing them. So the more we can reduce that light pollution and use light wisely, the more people will be able to share the wonders of the cosmos from wherever they are.
Yeah.
Indeed, and we're glad that everyone in Julian is working to try to educate everybody and to make the skies better in the community there as well.
Yeah, and we've got a new lighting ordinance for all of backcountry San Diego County.
which is awesome.
It's going to encourage other communities to seek dark sky community status and be part of preserving this incredible resource that we have. That no one should grow up without seeing the cosmos looking up.
Yeah, it's definitely something that gives you perspective.
Hmm. I think you appreciate the Earth a lot more when you get to know the cosmos.
Yeah.
Yeah.
It isn't like, there's probably 10,000 Earths out there nearby. I mean, there may be 10,000 Earths out there in the universe, broadly speaking, but yeah.
Yeah.
All right. Okay. And, Scott is also a director, I believe, of the Palomar College Planetarium. So I don't know if you want to say anything about that, but, if you want to get a little more knowledge about astronomy, that's one place to go.
Except we are currently closed due to COVID, and
Yeah.
I literally have not set foot in the building since March 13th because I'm
Okay.
not allowed to.
Yeah.
Yeah.
Well, hopefully that will change soon. We haven't done any in-person star parties either for quite a while, but get everybody vaccinated and get it back into the world. Science is the key to solving problems, whether it's space exploration or dealing with a nasty virus.
Mm-hmm.
Definitely
Okay.
agree.
All right. Well, good night, everybody. Again, thanks, Vivek and Scott. This was great. I'm glad that we have conquered the sound virus and not having more audio intrusion, unwanted echoes, and we'll be back. So keep in touch.
Mm-hmm.
Good night,
Okay.
everybody, and thanks
Good
for
night.
joining.
Good night.